piecewise functions, what are piecewise functions? Functions represented by a combination of equations, each corresponding to a different part of the domain. Here is an example of a piecewise function. So we have two separate equations and their domain. Evaluating piecewise functions. Determine which portion of the domain the value is in. Substitute the value into the equation for that portion of the domain. There will only be one answer. Okay, f of x equals x plus 2 if x is less than 2. And f of x equals 2x plus 1 if x is greater than or equal to 2. So, 0. Is 0 less than 2 or greater than or equal to 2? Yes, less than 2. So I'm going to substitute my 0 in for x into this equation. So 0 plus 2 equals 2. Okay, how about 2? Is 2 less than 2 or is 2 greater than or equal to 2? It is greater than or equal to 2. So I have to substitute it into this equation. So I'll have 2 times 2 plus 1 equals 4. Or 5, I'm sorry. Okay, how about 4? Is 4 less than 2 or is 4 greater than or equal to 2? It is greater than or equal to 2. So I'm going to substitute it into this equation. Okay, let's try another. H of x equals 1/2 x minus 10 if x is less than 6. And h of x equals negative x minus 1 if x is greater than 6. Okay. Negative 10. Is negative 10 less than or equal to 6 or greater than or equal to 6? It is less than or equal to 6. So we're going to use this equation to solve. So 1/2 times negative 10 minus 10 equals negative 15. So that would be negative 5 minus 10 is negative 15. Okay, how about 6? 6, is it less than or equal to 6 or greater than 6? Less than or equal to 6. So I'm going to substitute it into this equation. So 1/2 times 6 minus 10 equals negative 7. So 3 minus 10, negative 7. Okay, how about 8? Is 8 less than or equal to 6 or greater than 6? Greater than 6. So I'm going to substitute it into this equation. Graphing piecewise functions. Begin by substituting the pivotal value into each equation to find the start and stopping points of each graph. Okay, so we're going to substitute the value that is in for our domain. Then we're going to plot those points using the correct type of circle. So if it is less than or greater than, we will have an open circle. If it is less than or equal to, or greater than or equal to, we will have a closed circle. We continue the graph by using our M and B if linear, so slope and y-intercepts, or we can just, if it is not linear, we can pick values for x and plug it in to get y. The important part is that we are going in the correct direction according to our domain. Okay. So for this equation here, I'm going to substitute in my pivotal point here, 2, into my first equation. So that's going to equal 3 1/3. Okay? So at 2, 1, 2, I'm going to be at 3, 1, 2, 3 1/3. So about here. And this is greater than, so it's going to be a open circle. Okay, now let's find the other one. We'll continue graphing this one in just a minute. So negative times 2 plus 1 will equal negative 1. So at 2, we're going to be at negative 1. And this is going to be a closed circle because it is equal to. Okay, now let's go look back at this one. So I'm looking at my equation here, and I want my x values to be greater than 2. So I know that I'm going to be going in this direction. I have a positive slope, so it's going to be going up and to the right, and my y-intercept is at 2. So I'm going to make an imaginary point here at 2, okay? It's just going to help me plot my additional points. So my slope then, I'm going to rise 2 values and run 3 values, 1, 2, 3. So that point would be here, okay? And then I'm going to do that again, rise 2 values, run 3, and that point would be here. So my line is going to look like that. Okay, now let's work on the next one. So this one has to be less than or equal to 2. So it's going to have to go this direction. And my slope is negative, so it's going to have to lean this way. So, and my slope is negative 1, so I'm going to go up 1 and 1 to the left. Up 1, 1 to the left. Up 1, 1 to the left. And if you see, my y-intercept is 1, so, and that makes sense. Okay, let's try another value, or another example. F of x equals x if x is greater than 2, and f of x equals x minus 4 if x is less than or equal to 2. Okay, so the first thing I need to do is substitute in my pivotal points. So I'm going to substitute in 2 into this equation. So at 2, my point will be at negative 2, and it's going to be open. So at 2, I'm going to be at negative 2, and it's going to be open. Okay, now let's substitute this in. So 2 times 4 is negative 2. Okay, and at this point at 2, we're going to be at negative 2 as well, and it is closed. If the points overlap, that is fine. It will look like a closed circle unless both of them are open. But that can't happen here with a function. Okay, so now let's think. Let's look back here. So my slope here is negative 1, but it needs to be greater than 2. So it's negative slope, so it's going to lean this way. And it has to be greater than 2, so it's going to definitely go in this direction. And it will be up 1 and 1 to the, down 1 and 1 to the right. So it's going to go in this direction, It's negative. So down 1, 1 to the right, down 1, 1 to the right, down 1, 1 to the right. And there you go. Okay, now let's think about this point here. It is less than or equal to, so it's going to be going in this direction. And my slope is 1, so it's positive, so it's going to have to be going this way. And my intersecting point is at -4. So that is here. So that is my graph. Okay. So let's try another. Okay, so f of x equals x plus 4 if x is less than -2. F of x equals 4 if x equals -2. And f of x equals x plus 6 if x is greater than -2. Okay, let's substitute in our points. So -2 plus 4 equals 2. Okay, this is the same as a point. If x is -2, my y, f of x, is 4. Right. 4 there. -2, 4. Okay. If this was less than or equal to, it would be a straight line. Okay, x plus 6, okay, so let's substitute that in. -2 plus 6, which is also 4. Okay, so let's plot these points. Okay, so at -2, we're at 2. So -2, 2, and it is an open circle. And at 2, -2, we're at 4, and it is a closed circle because it's equal to, or equal. And at -2, we're at 4, and that is an open circle. Okay. And then remember again, if they overlap, it's fine. So now let's draw our graphs. So for this equation, my slope is 1, and I'm going less than -2. So I know I'm going to have a positive slope, so my slope's going to be like this, but it has to be less than 2. -2. So it has to be this direction here. And it's 1, so I'm going to go down 1 and 1 to the left. Remember, 2 negatives makes a positive. Okay? And then remember, this one is just a point, so there's no line. However, if it was like less than or equal to, then, or greater than or equal to, it would be a line this way. And if it was less than or equal to, it would be a line this way. However, it's not, it's just a point. Okay, so now let's look at this one. My slope again is 1, so it's going to be a positive slope, so it's going to be in this direction. And it is greater than -2, so it has to be pointing this way, so it's going to be going up. And it's 1, so 1. And then let's check to make sure that makes sense. So my intersecting point here, my E, is at 6. So 1, 2, 3, 4, 5, 6. That makes sense? Okay. So that is graphing piecewise functions. Now let's talk about graphing step functions. So a piecewise function whose graph resembles a set of stairs steps. That is a step function. And this is an example. So if f of x equals 1, our x is between 0 and 1. If f of x equals 2, our x is between 1 and 2. And if f of x equals 3, our x is between 2 and 3. And again, if f of x equals 4, our x is between 3 and 4. So it's very similar to graphing. So I'm going to be, my x, when it's at 0, my y value is 1. So 0, 1. This is a closed dot. Okay. And it is x is greater than or equal to, so it's going to be going this direction. Okay, when x is 1, it's at 1, and it's a open dot, and it's less than. So it's in between there. Okay, so now if x is at 1, then our y is at 2, and it is a closed circle, and it is greater than, so it's going to go in that direction. And at 2, it is at 2, and it's an open circle, and it's going less than, so it's in that direction. So then at 2, we're at 3, so 2, 3, closed circle, and it is greater than, and at 3, we're at 3, and it is an open circle, and we're less than. So x is at 3, it is at 4, so 3, 4, and it is a closed circle because it is greater than or equal to. And then we are at 4, 4, and it is an open circle because it is less than. And there you go. Okay, let's try one more step function. So, if f of x equals 6, so if y equals 6, then my x values are between -4 and -2. If f of x or y equals 4, then my x values are in between -2 and 0. If f of x equals 2, then my x values are in between 0 and 2. And if f of x equals 0, then my x values are in between 2 and 4. So let's start this off. So at -4, so my x value is at -4, my y value is at 6. So -4, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. And that is an open circle. Okay, then if we're at -2, we're at 6, and that is a closed circle. So here, my x is greater than -4, but less than or equal to -2. So that's where we get this line in between. Okay, at -2, I am at 4. -2, 4, 1, 2, 3, 4, and it is an open circle. And it is greater than, and then at 0 we're at 4, so 0, 4, and it's a closed circle, and it is less than or equal to, so the value's in between there. Okay, did I skip one? Yeah, no, at 0 we're at 2, so 0, 2, and that's an open circle because it's less than, and it is or greater than, I'm sorry, x is greater than 0, so it's going to be going that direction. And at 2, we're at 2. And it's a closed circle because it's equal to, and it is less than or equal to. So it's those values in between. Okay, and then at 2, we're at 0. So 2, we're at 0, and it's an open circle because it is greater than. And then at 4, we're at 0, and it's a closed circle, and it is less than or equal to. So those values in between there. So that is graphing step functions. Your homework is page 5, question numbers 27 and 29, and page 9, numbers 1 through 18 and 21. If you have any more questions, come see me for tutoring.